Hey, Gregory Carlson here for the Calculus Building. Let's do some more practice of second-order derivatives. If you're feeling brave, you should go ahead and try these on your own first before I do them to see if you got it, and then see if your answer matches my answer. So do that now. Pause the video or pause it before each problem and see if you can get it, and then see if you get the same thing as me. So again, this should say, assume that f of x equals x to the 1/7. Then find the derivative. So I'll fix that in your notes. Okay, so let's find the second derivative of x to the 1/7 power. The first derivative would equal, we bring the 1/7 down, and it would be x to the 7th minus 1, which would be -6/7. So there's the first derivative. The second derivative would be, do the power rule. We bring down our power, multiply it, so that would be -6/49 x, and we would subtract 1 again, which means -7/7. So we would get that. So notice that every time we take a derivative of something with x, if we have an x to a power in the denominator, when we take the derivative, the sign flips every time because we have a negative up here. And so we bring it out, it flips the sign back and forth and back and forth. How about number 2? Find if f of x equals this function, then find the second derivative. Now, this one's interesting because we're going to do the chain rule in addition to this. So f prime of x, doing the chain rule, we do 7 times x squared plus 8, and we drop the power down to the 6th. So there's the first part of the chain rule. And now we multiply by the derivative of the inside. So now this is very interesting, because what we have now is we're going to take the second derivative, and now we have a product rule. So sometimes when you're doing multiple derivatives of things involving the chain rule, they can get quite complicated because the chain rule takes the derivative of the inside, which can give you a whole bunch more function to take the derivative of. So we're going to do the product rule, and this 7 I could factor out of the entire derivative and then slap it back on at the end. But instead, I'm going to just do this. I'm going to say that that's f, that's g. So let's do the product rule. So the product rule is this f times the derivative of g plus, so that's f times the derivative of g, so 7 times x squared plus 8 to the 6 times the derivative of g. Now we're going to do the derivative of f. And remember, now we're going to need to do the chain rule. So that's going to be 42, because 6 times 7, x squared plus 8. And now I need to multiply that by 2x, because that's the derivative of the inside. So we did f times the derivative of g, and then we do the derivative of f, which is all of this, and now we need to do times g, which is times 2x. So we could simplify that a little bit, but I'm not going to go crazy. 2 times 7 is 14, x squared plus 8 to the 6. And then 42 times 2x would be 84x. In fact, that would be x squared, and I have another 2 I can multiply it by, so that would be 128 x squared. And that's being multiplied by x squared plus 8. So that was just a little bit of algebra to clean that up a little bit. So just be careful with the chain rule. The chain rule can make a lot more work for you sometimes when you are doing these. That's right? 42 times 4? Sorry, that should be 168, not 128. Just saw that and I was like, that can't be right. 168. Okay, let's do the second derivative of this. Y equals all of this. It's here we go. This is going to be another chain rule problem, so this one's going to be tricky, I bet. Now notice I just put y prime. That means dy dx, and so if you just want to write y prime, that's just shorthand for dy dx. We'll do the chain rule, so 6/7, derivative of the outside, leaving the inside intact. Take 1 off of that, which would give us negative 1 over 7. And now multiply by the derivative of the inside. So that would be 9x to the 8 plus 1. So notice that doesn't have a power because that's just the derivative of the inside with the chain rule. So you can see that this has created a lot more work for us to do for this second derivative. So again, I'm just going to call this f, and I'm going to call this g. And this is going to be a great example because we're going to have chain rule on both sides of the product rule for this. So in fact, remember, it's fg prime plus f prime g. So we're going to have chain rule on both sides of that. So here we go. F okay, that's just f, so no chain rule there because we just put down f. Now we're doing the derivative of g, and the derivative of that, well, I guess you don't really have the chain rule as much here. That's just 72x to the 7. Okay, so that's f times the derivative of g. Now we're going to do the derivative of f times g. So the derivative of this is going to be negative 6 over 49. Because again, we're doing the outside derivative. So bring that down, leave the inside intact. Now take 1 off of this, which would make it negative 8 over 7. And now finally, we need to multiply by the derivative of the inside to complete the chain rule. So that'll be 9x to the 8 plus 1. Phew, that's a long second derivative. But there's your answer right there. And I'm not even going to try to simplify that any further than what it is right there. So if you wrote that as your answer for this problem, I'd be very happy. So complicated function, as you take the derivative, it's going to get more and more complicated. All right, let's do a few more. We have y equals all of this, and we want to find the second derivative. I would consider recommending foiling this and then finding the second derivative because that would probably be easier. But just to show you, just in case you couldn't do that, I'm going to show you how to do this. So again, it's f prime or fg prime plus f prime g. So f times the derivative of g plus g times the derivative of f. So there you go. I kind of flipped those two, but f times the derivative of g plus g times the derivative of f. So there's that first one. So let's go ahead and find the second derivative. The 4 can just come out, and so that's just going to be 4 times 2x, which is 8x. Do you agree with me there? Again, I can do that because that's just a constant, okay? We don't really need to do the product rule with just a constant right here. I mean, you could do the product rule and you'd get a 0, which would cancel. But I'm trying to show you that this would be 4x squared minus 4 if we distributed, and the minus 4 would have nothing, and then 4x squared would become 8x. So I hope that makes sense. Now here we do need to do the product rule because I have functions here, and this has an x within it. So this time we will do the product rule. So it's not just a constant, is what I'm trying to say. So 4x plus 3 times the derivative of 2x, which is 2, plus 2x times the derivative of 4x plus 3, which is 4. So let's clean that up. So y prime prime equals, that's 8x over here, so that's going to be 16x plus distribute 8x plus 6. So y prime prime is equal to 24x plus 6. Okay, so that was quite a bit of work, and there's a lot of dodging we had to do, being very careful with the product rule. Let me show you why it would have been easier to FOIL it. If you FOILed this, it would have been 4x to the 3 plus 3x squared minus 4x minus 3. And so that's y. So this is why it would have been easier. Y prime would have equaled 12x squared plus 6x minus 4, and y, because the 3 would have gone away, and y prime prime would be 24x plus 6. So same thing if you FOIL it. Isn't that great how it all just works together? You see why I love calculus so much. So obviously this way is easier, but I just wanted to show you this tricky product rule, just in case you had a square root in here or something that you couldn't FOIL as easily or something. One more part on this to go, I think, and I will do that in the next video. If you like this, if you found it helpful, please make sure you like, share, and subscribe.